Let's talk non-planar graphs. What is a graph? A graph is just this thing, a bunch of vertices and possibly edges between them. A graph is planar if you can draw them on a plane without edges crossing. So these are some examples of planar graphs and these are some examples of non-planar graphs. Notice the crossings on those non-planar graphs. Emphasis on the can part, by the way. This graph seems like it's non-planar because of that crossing, but if you take that edge and move it to the outside, you actually remove the crossing. So this graph is actually planar. Basically, a graph is non-planar if it is impossible to draw it without crossings. The most famous non-planar graphs are these graphs called K33 and K5, and they are sort of like the prime numbers of non-planar graphs. Let me explain. There's a theorem called Kuratowski's theorem which states that every non-planar graph contains a subdivision of K33 or K5. Basically, if I give you a non-planar graph and you search hard enough, you will definitely find a K33 or a K5 inside it. So for example, this graph is non-planar because there's a bad boy, this one. Why should we care about planar graphs? I'm glad you asked. Bold of you to assume that mathematicians require a reason to study things. But there are applications. If you are designing a circuit or a road system, it helps if the graph is as planar as possible. Because if there is a crossing, that would mean you need to have a y-cross or a bridge respectively. And planarity is a huge research area in graph theory. There are loads of theorems which apply to planar graphs. The most famous of which is probably the four-color theorem, which will be a topic of an upcoming short of mine, so stay tuned.